There have been lots of changes in the JavaScript area over the past couple of years. Browsers essentially are compiling JavaScript. JavaScript is becoming more and more important, especially with regards to HTML5 and CSS3. JavaScript is, like it or not, going to be a language we're all going to be using. Now, if you've been developing in ASP.NET or ASP.NET MVC, you may already have been starting to write some JavaScript. JavaScript is a weird language. Oops, I don't know where that went to. There we go. It's a weird language because it has a C-type syntax. And because it has a C-type syntax, you may be thinking you're already familiar with how JavaScript works. That could not be further from the truth. JavaScript is a very weird language in many respects, and I'm going to be talking a little bit about the problems you may find when you're writing JavaScript. It's a loosely typed language for a start. Now, when I say loosely typed, there are types in JavaScript, but they're associated with a value. They're not associated with a variable. I can declare a variable to have some kind of string value, for example, and then in the very next statement, redeclare that variable to have a number in it. So the values have the type, but not the variables. That's very different from C#. C# is a very strongly typed language. Even with the var keyword, you're still using strongly typed syntax. It's also, JavaScript is also a functional language. Functions are objects. This is the one thing I had to basically drum into my head when I first started doing JavaScript. Functions are objects. They can be passed around. They're not tied to some class somewhere forevermore as a method. They are an object in their very own right. They can be returned from other functions. We have the basis of a functional language here, and they can form closures as well. So they form lambda expressions, if you're used to that from Link and C#. I said there are types in JavaScript. There are a minimal number of types in JavaScript. There are only 6. The 6 are Boolean, number, string, object, null, and a very weird one called undefined. Boolean is the simplest one. 2 values, true and false. There's a type of operator in JavaScript. Type of will return the string lowercase Boolean. Ignore the constructor thing. Now, JavaScript is a bit like C in a way, in that when you're evaluating a conditional expression, in C, you can have an integer expression as your conditional expression. If it evaluates to 0, then the conditional expression is assumed false. If it evaluates to anything else, it assumes true. In JavaScript, there's something similar to that, and they're called falsy values because they're false-like. There's the obvious one, which is false itself, which is of the Boolean type. 0 of the number type. Not a number of the number type. If you go, if some value, and that some value happens to be nan, then it will evaluate as false. Empty string is another one. Null evaluates as false, and undefined itself evaluates as false. We'll see a couple of examples of that. I have some code bits to come up. Number, it's directly equivalent to the double type in C#. There are no integers in JavaScript. All numbers are stored as doubles. Now, in general, this doesn't really affect you very much, but you have to be kind of careful when you're doing equality texting with double type, just as in C#. So if you're mixing your decimal values with your integer values, beware of that kind of problem. As I say, no integers in C#. Bizarrely, JavaScript does have bit operators. What happens when you use a bit operator like shift left or shift right or something, What actually happens by the interpreter is it takes your double value, converts it to an integer internally, does the bit operation, and then converts it back into a double. So if you want to divide by 2, you can still shift left 1. Type of returns number and ignore the constructor function. String, another gotcha. It's not like C#. String in JavaScript is just a sequence of 16-bit characters. There are no composite characters. There's no surrogate pairs, anything like that. Each 16-bit value is assumed to be a character. End of story. So beware, you're in the first plane for Unicode, and you can't get out of it. Type of operator returns a string on a value. Object. Object is the fundamental type in JavaScript. An object in JavaScript is not like an object in C#. An object in JavaScript is essentially, under the hood, an associative array or a hash table. It's, if you like, a set of key value pairs with a key being the member name or the property name or the method name, and the value being whatever the value of that property, method, or whatever happens to be. And the keys are always strings. We'll talk a little bit about that in a minute. Objects are passed around by reference only. There are no structs or anything like that in JavaScript. Objects are just passed by reference. So you can copy the reference for an object, if you like, in between variables. Type of returns object. Now we get some fun stuff. Null. It has a single value. Null. Unfortunately, the type of operator is broken in JavaScript. It returns object. It should return null, but it returns object. Something to watch out for. Undefined, a single value again. Undefined is a peculiar value for JavaScript. Essentially, it says this particular variable you're referencing doesn't exist. That's undefined. The broken thing in JavaScript essentially grew up with Netscape back in the early 90s. And for some unknown reason, undefined is not a keyword in the language. It's actually a variable, and you can assign something to the variable called undefined, and you'll break code. Type of operator actually returns undefined. It has no constructor function. Oh, void is a weird operator. Apply void to any variable value whatsoever, it always returns undefined. We'll talk about void with regard to return types and functions in a minute. Oh, before I do that, let's have a little bit of fun. What I'm going to show you. Oh, by the way, yes. Just to show that it's not all .NET, I'm using Mac OS X here, okay? So, excuse me while I bring up TextMate. If I could find out where. Oh, there we are, TextMate. Can you see that, or is that not? Is that a little too small? Let me see if I can't grow the text size a bit. Okay. Let's go a bit larger than that. Maybe a bit more. Okay, we should be able to see that. Right, what I'm defining up here is just a bunch of quick examples, if you like, of JavaScript. This is a function. Don't worry about it. It's just for convenience sake. I'm just declaring a function called CL, which will output to the Firebug console. So here I have a variable, b. I'm declaring it as true. I'm going to basically print the type of b and its constructor. Here's a number, n. And same thing, there's a hello world here. Where are we? Yep, hello world. Here's an object where I'm setting a couple of values. Don't worry about the syntax at the moment. Here's null, and so on and so forth. So let me just cut all that. And what I'm going to do is copy it into... okay. into, come back. I'm going to copy it into Firebug. Firebug happens to be my preferred way of playing around with JavaScript. It's an add-on for Firefox. I'm using Firefox 4 here, I think, or maybe it's still 3. So I basically pasted that code in. I don't particularly want to, create an HTML page just to run this. Firebug is great. It's easy. So what I have here is, my B value is a Boolean type. It returns a constructor Boolean, number, string, object. Null returns object, type of, as I said. Undefined returns undefined. Ignore the final undefined there. So just a quick example of, what thing is about JavaScript is it's easy to play around with it in the small. Playing around with it in the large, with a large code base, tends to be really difficult. So I often play around with Firebug like this. So, I didn't want to do that. Additional types. There are two kind of additional types. There's arrays. We'll talk about them in a minute. Type of an array returns object. Arrays are objects. The constructor function is called array. And there are functions. And the type of on a function returns function. And the constructor function is function. Now, objects as hash tables. As I said before, earlier on, an object is a very fluid thing. It's essentially a dictionary or a hash table or associative array. And the properties and members of the object are key-value pairs. The keys are strings, as I said. And you can access a value of a member by either the dot notation, the dot operator. So we've got here myObject.name. Or you can use the indexing operators, the square brackets. Both of those are equivalent. The interpreter will compile them both in the same way. And you can easily add or remove properties. An object is not fluid in any sense whatsoever. So let me just flip over to my TextMate again. And, oops. There we go. Don't want to do that. Right, what I've got here is, ignore my little helper function at the top. So what I'm going to do here is declare a circle object. This is a shorthand literal for declaring an empty object, the open close brace. I'm then going to create a new property called radius, set it equal to 10. I'm then going to create a method called getArea, and I'm declaring it as a function, and the function is going to return math.py times the radius times radius, this dot radius times this dot radius. And then I'm going to call it and print it out. Then I'm going to use my little helper function there to list the members of a circle, so you can see that they've just got radius and getArea. And then I'm going to add another property and then delete it. So let me copy that code and run it quickly in, whoops. Yeah, I should be using my keyboard here. Here we go. Okay. So let's clear this and paste that in. And we'll clear this. So let's run my little bit of JavaScript code here. My helper function basically, okay, here's first of all the call to getArea here. So essentially pi times 10 by 10 is 314 point whatever. So notice it is a double number. And here I'm basically listing the members of my object. I have radius of 10. GetArea is this function. JavaScript is an interpreted language. It maintains, the actual code. I'm just printing the code. So, and then what did I do? I added the color property, so color red at this point here. And then I deleted that property and listed all the members again, and I just get the radius and the get area again. So, as again, objects are not fixed as in C#. They are very, very much fluid. Got the right key now. No? Yes, Shift F5. So, creating a new object, the best way is actually to use the object literal syntax. You basically have an open brace and a closed brace. So the first item there, example there, shows an empty object, no properties, methods, or anything at all. The second example there, the circle one, shows creating an object which has two properties. One is radius, the other one is color. And those of you, who knows JSON, the data interchange format? JSON, the data interchange format, is based upon JavaScript's object literal syntax. So you have open brace, name of property, colon, value of property, comma, and continue that until the last one, and then close brace. Silly way, you see this sometimes in code, it's bizarre, is to use new object. Nobody does that who's really a JavaScript programmer. And the extremely silly way is that one at the end, which basically creates a new object based upon the object prototype. Prototypes. Inheritance in JavaScript is not through classes. There is no class model in JavaScript. There are tools, libraries out there which pretend to be a class model for JavaScript. The most famous one is called Prototype. MooTools does some kind of class model for JavaScript. jQuery does not. So you don't write a class. You don't then create new objects from it, just like in C#. The inheritance model in JavaScript is prototypal, as it's called. All objects descend from other objects or inherit from other objects. Essentially, the way it works is you define some interesting object, some properties, it has some methods, it has this, that, and the other, and then you create new objects based upon that prototype. So you create a prototype object, and then you create other objects based on it. And then you customize your new objects if you need to customize your new objects. There is, as you saw earlier on, a way to use the word new, the keyword new, with a constructor function. It's handy. It's confusing. I would get to know prototypal inheritance before you start using constructor functions. Now, the way it all works is that every object has a hidden link. It's built into the infrastructure for the object, and it's a hidden link to its ancestor. In WebKit browsers, they expose this as _proto__. Only in WebKit browsers is this available. It's non-standard. If you use Internet Explorer, it's not there. If you use Opera, it's not there. If you do need a visible link, so you need to walk the prototype chain, as I'll show you in a minute, then basically just create your own property which does that for you. Now, when you reference an object member, what actually happens is the first thing that happens is the interpreter looks at the object you have. Let's say I'm looking at the radius property. So the interpreter says, oh, I've got a circle. I'm going to see whether it has a circle property, a radius property. Yes, it does, and it stops. Now, let's suppose that circle inherits from the shape object. What happens here is the interpreter starts off with a circle object. Does it have a color property? No, it doesn't. It then goes to the prototype, picks up that object, and then says, do you have a color property? Yes, you do. And it continues down the prototype chain like this. The ancestor of all objects is called object.prototype, and it has various functions which are kind of nifty. One of them is toString. So if I did circle.toString, what would happen is the interpreter would walk down the prototype chain from circle to shape to object.prototype, find toString, and then call it. In the very latest browsers, so we're talking IE 9, Firefox 4, Safari 5, there's a method called object.create. Object here, by the way, is a function, and create is a method on the function. Functions are objects. Objects can have properties and methods of their own. So can functions in JavaScript. Another weird thing, you don't talk about properties of a method in C#, but you can in JavaScript. You don't talk about methods of a method in C#. Don't even know what it would mean. Let's grow the... grab that. Okay, this is, quote, real JavaScript now. I'm declaring object.create to be equal to object.create. What happens here is one of these, it's a conditional expression. It evaluates it to be true or false. And the way it evaluates it is to say, well, does object.create exist? Is it undefined? Is it null? Is it zero? Is it empty string? Is it false? Or whatever it happens to be. If it exists already, then this will evaluate to object.create. So I'm just setting it to itself. If it doesn't exist yet in earlier browsers, then set it equal to, this is the OR operator, to this function here. Function takes an object with a property object, if it wants some extra properties on the object, and it does this stuff. Very weird code. Declaring a nested function, I'm setting the prototype of the function to my object, I'm creating a new object out of that new constructor function, that's a constructor function. And if property object was passed in, then I copy over some properties. That is idiomatic JavaScript. It's very weird to look at. This for statement here is cycling through all of the members of this object. It does a quick check to see whether it's a property of that object or whether it's a property of the prototype chain. If it's a property of the object, then it sets the resulting object's name, the property, equal to the property object's name. Weird. It took me, I don't know, a good day to understand what it was doing. Boom. Arrays. Oh. How am I doing? Oh, wonderful. Arrays are objects, and they're dead weird compared with C#. C#, you know what an array is? It's a contiguous block of memory equal to the length of the array, and you have the individual elements of the array, and they're right next to each other, and you know this kind of thing because it's efficient, and you can, everything appears on a memory page and stuff like that. It's just great. In C#, arrays are objects, and the elements of an array are essentially key-value pairs again. The key is actually the index as a string. You're using a hash table as an array, essentially, with all the keys being indexes. So you have the index 0, you have the index 1, you have the index 2, all strings. The weird thing about arrays, again, is length is automatically calculated for you. It's equal to the largest index plus 1. It's a special property. Because it's a special property, you can't inherit from arrays, which is kind of a shame. The array does not have to be, the elements in an array don't have to be all the same type. You can have arrays with, some elements as strings, some elements as objects, some elements as arrays. It doesn't matter. And you saw 4 in just then. Don't use it with arrays. You should use the ordinary numeric 4. I think I have, another bizarre thing about JavaScript. Only fixed in ECMAScript 5, or the latest JavaScripts. Trying to work out if you pass an object and whether it's an array or not is really difficult. Type of whatever you passed in returns object. That doesn't help you. The object could be, instance of is an operator. Not JavaScript operator. So you could say object instance of array, because array is the function, the constructor function. So it's pretty good, but it doesn't work if the object is in a different iframe. ECMAScript 5, the latest JavaScripts, you can actually use the method array.isArray, returns true or false. Up to now, the libraries, JavaScript libraries, have used this weird bit of code, object.prototype.toString of the object. If it returns object array in square brackets, then it is an array. That's actually defined in the standard. A very weird bit of code. But we'll soon all be using the latest JavaScript, so we won't mind. Creating an array, we have the usual constructor type. Nobody uses that. It's much, much better to use the literal form. So we have an empty array as the second item there. We're setting A is equal to the empty array. There's no need to declare an initial size. It's calculated automatically. And here's an example of a weird array where I'm setting an array to have 4 elements. The 0th element is 1. Element 1 is 2. Element 3 is the string 3. Element 4 is true. And it's much easier to read that style of array declaration. Oh, yeah. You can remove elements. The delete keyword we saw before briefly removed a member out of an object. Delete also removes, well, because each element is a member of the array object, you can remove it using delete. The unfortunate thing with that is it just sets the element to undefined. It doesn't actually close up the gap, as it were. So there's a method on the array called splice, which is inherited from the prototype. Which will actually splice up and remove the gap. Got a bit of code for that. Oh, don't want to do that one. Okay, start this again. Okay. Bring TextMate back in. Okay. Where's my mouse gone? Oh, there it is. Okay. All right. Let's drag this down a bit. Oh, we did have a bit of code on that. Yeah. So what the code I have here is a little helper function to begin with. I'm declaring an array with 3 elements. I'm just going to output what the length is. I'm going to basically set the 3rd element without increasing the, quote, length of the array, and then displaying the new length, just to show it actually gets automatically updated. And then I'm going to add an element at the 5th index, and we'll output the length again, and then we'll list the elements of A. So let me do this, including my helper function. There it is. And bring back Firefox. Here we go. Okay, we don't want to look at that. Right. Let's clear the output screen, output console. So that's my code. We'll just briefly run it. So my original length is 3. I had 3 elements. I add a 4th element at index 3, and the new length is 4. I didn't have to change the array. I didn't have to reallocate the array. I didn't have to do anything like that. Remember, arrays are objects. Objects are hash tables. And then I set the element index 5 to some string value. And notice the length is actually now 6. 6 is 1 more than 5, and JavaScript basically automatically sets the length to, or computes the length of being the largest index plus 1. And then, just for fun, I list the elements of the array. So we have 3, 1, 4, 2, which is the values I set in. Element 4 is actually undefined. So this is where undefined comes in again. And element 5 is no more. So there are 6 elements in this array, of which the 5th one is undefined. Other weird things while I'm here. Got caps lock on, sorry. A dot foo. I can't spell either today. There we go. And I can run this. I have to do that. Okay. But essentially what I'm trying to show here is that arrays, even though they're called arrays and have semantics which are array-like, they're also objects. So I can set a new property, and I'm calling it foo, on the array. This is the biggest reason why you shouldn't use the for-in structure or statement, since that just basically goes through all the properties, no matter whether they're numeric indexes or whether they're property names like this. To go back to it again, functions are objects. A function is some encapsulation of some code. JavaScript stores the textual version of that code, if you like, as the object. Modern browsers with their JavaScript compilers will also compile it and store it as a compiled form. Things like Chrome's V8 engine and SpiderMonkey and whatever the new one is called in Firefox. And as an object, it can have properties and methods of its own, as I said earlier on. Properties can appear as a parameter or return from another function, going back to the old functional aspects of JavaScript. And again, they're passed by reference and not by value. So when I copy a function literal into a variable, and then copy that variable to another variable, what's actually passing around is the reference to the function code, not the actual code itself. Defining a function, we've seen several examples very quickly. The main way, and the way I've essentially tried to teach myself, is to define it as a function literal. In other words, the first example there where we have f is function, the keyword function, some arguments or parameters, and then some code in braces. You can also give, with a functional literal, you can give it an optional name, not supported by all JavaScripts by any means, bit dodgy, but it's an easy way of doing recursion. You can refer to the optional name inside the function. But as I say, IE6, don't do this. Or you can declare it as function statements, which is kind of what you're used to in C#. So you have function, name of function, arguments, and some description. The interpreter will, in practically 99.99% of cases, convert that last version automatically into one of the other versions. There is one case where it works slightly differently, but it's just not worth worrying about. The other thing about using the var some function name equals is you're automatically saying to yourself that functions are objects. You're going to be passing around this function in some sense. It becomes easier to understand. Huh. Yes. If I go back, notice there's no function result value. There's no function result type, I should say. And the reason is basically all functions return something. There is no void type. You can't just return void if that ever made sense. You either return undefined if you haven't actually specifically stated what the return value is, or you are going to return some value. And there's an exclusion to the rule, exception to the rule, unless it's a constructor and is called via new, and then it returns the new object that you're creating. This is kind of handy. When you invoke a function, the function will actually get two extra variables, two local variables. The first local variable is this. It's such a shame because it doesn't work like this in C#, and yet everybody that I know, including myself, tend to assume that the this in JavaScript is equal to the this in C#, and it's not. It's very complicated. Oh, all right, there are 4 rules. Memorize the 4 rules and you'll be okay. If you don't memorize the 4 rules, you'll get caught out, hence the evil laugh. And the other extra local variable you get is an arguments array. You get all of the parameters passed to the function as an array. The reason for this is in JavaScript, the number of parameters you pass to a function does not have to equal the number of parameters defined on the function. You can pass more parameters to the function, or you can pass less parameters to the function. Doesn't matter. And the arguments array is one way to find out how many arguments or parameters you were actually passed, so you can do something with them. As I say, there are 4 invocation patterns. There's method, function, constructor, and the apply invocation. We'll quickly go through these. Method invocation is the one we're all used to in C#, because all methods are defined on a class. If they're static, then you call that method through the class name. If they're not static, then you have an object, and you call the method through the object. So method invocation is you define a function on an object, and you call it via that object. And what happens here is the thing you really like, and that is this points to the object containing the method, which is great. The next one is not so great. It's function invocation. You define it any old how you want. You can either have it as a global function, you can have it as an internal nested function, you can declare it as a method on an object. It doesn't matter. if you call it via the function invocation, you're not actually going to call it with regard to an object at all. And what happens then is this points to the global object. And this catches everyone out. But you might say, what is the global object? The other naff thing about JavaScript is there is an object which contains everything where you forget to give it an address, if you like. The global object has no name. It's where all, as I say, all unknown variables, be they primitives, functions, objects, arrays, whatever, they end up as public members. They're visible everywhere to all code. I don't know about you, but global variables scare me. JavaScript makes it so easy to create global variables, it becomes really hard not to create them. The browser actually sets up a special property called window, and that points to the global object. It's a property, so window, the property, is actually a member of the global object, and it points to the global object. It's a recursive definition. So if you look in Firefox, for example, in Firebug, for example, at the DOM, you can see the global object, and it has a property called window. And if you look at window, it has all the properties of the global object, including window, which has all the methods of. So the global object is kind of interesting, but you've got to be really careful about it. Creating global variables that are publicly visible is bad news in any language. And in JavaScript, it's doubly so. I could, for example, set window to null. And what would happen is, I don't know, all my libraries that I use, like jQuery, for example, would then just... Actually, jQuery would work, but a lot of code would actually break. Third invocation type is constructor invocation. We're using the new keyword. It's defined as a function any way you like. There is a convention here. There is nothing in JavaScript which says this function is a constructor, this function is not a constructor. All functions look alike. So we have to have a convention to try and help maintenance programmers with knowing that a function is a constructor, to be used as a constructor or not to be used as a constructor. And the convention we use is the initial uppercase letter convention. If you notice the code I have is Pascal cased with an initial lowercase letter. This is the only case when you really use an uppercase letter. It's called withnew. This points to the object being constructed. Essentially, when the new keyword gets executed, an object is created. This is set to that object, and the constructor is called. And you don't have to return that object. It's done automatically for you, so there's no need for a return statement. And in fact, you can return any object whatsoever. You don't have to return the one that's just been constructed. Next one is kind of fun. It's the apply invocation. This is a way of calling a function and basically saying, okay, I want you to call this function, and here's an object which is going to be the this local variable. And it's an apply method. It's on the function itself. There's another method called call, and it gets really hard to, you call on the function. But essentially, it's a way of passing the this parameter that you want. You're binding the this parameter, the this local variable, to some object. As I say, you get to define the this object. Here's another one for C# programmers. Scope in JavaScript is by function. It is not by block. It's another one that kind of catches people out. So when you have braces in C#, you can declare a variable inside those braces. That variable is only visible inside the braces. The scope is the braces. That's not what happens in JavaScript. JavaScript, the scope of local variables is to the called function. If you have nested functions, this behaves differently. This is a local variable, but it stays with the outer function. You can't see it inside the nested function. And nested functions get their own this variable, and it's usually the global object. And the way this catches people out is with callbacks. I'll give you a quick example in a moment. Another weird thing, in C#, you declare a local variable. That local variable is only visible after the declaration of the local variable. In JavaScript, it's not. You declare a local variable, it's visible throughout the function, throughout the scope. Obviously, if you haven't set the variable to anything, then it's undefined, but it's visible throughout the function. So in JavaScript, the recommendation is to declare your variables right at the top of the function and then declare the code of the function itself. If anybody knows Delphi, that's what you do in Delphi. You declare a var block. But this closures in JavaScript are the most amazing things. It's the great thing about functions, and closures in JavaScript negate all the bad things about scope and about those kind of issues and this parameter and whatever it happens to be. Closures just make JavaScript what it is. It's a fabulous thing. So let me not do what I just did. Go back to a little bit of code. Right, this is a fun little function. I'm declaring a function called f. It's a function. F is a function. I'm going to take a count value. I'm declaring inside it a tick function. Tick is a function. The function will display an asterisk, decrement count. If count is non-zero, that's what that means, then it's going to set a timeout to call itself for 500 milliseconds. Set timeout is a JavaScript standard function, and what it does is to basically set this function on a stack, if you like, and it will call it after 500 milliseconds. And then, so that's the declaration of tick, and then I call tick. And that's the end of my f function. And down here, I'm going to call f with a value of 10. Now, before I actually run this, so you can see what happens, I want to point out various things. First of all, in my tick function here, I'm making reference to count. Count is declared in my outer function. So the scope of count is within that brace and that brace. So it's declared everywhere between those two, including inside this nested function. And this is where the weird thing happens. When I call f10, it's going to, okay, doesn't really do anything with that, apart from compiling it. Calls tick. Tick then does this, and then defers execution of tick again for 500 milliseconds, and then f will finish. 500 milliseconds later, tick starts up. But f has already finished. F is completed. I have created a closure on f so that tick can continue to work even when f has finished its actual work, its execution. So let me just copy that over to Firefox. Okay, clear. weird thing is, okay, that's the call to F. It outputs calls tick and outputs the asterisk, and that's the result value of F. So don't worry about the undefined bit. I didn't have F return anything, so it returns undefined. And then F has finished execution, but the closure of F so that tick can continue to work is still around. Closures are that easy in JavaScript. How many people have actually created a closure using lambda expressions in C#? I have 1 or 2 hands up. It's not that easy in C#. It's really hard not to do in JavaScript. It's that simple. And this illustrates the whole point about scope and all this kind of stuff. The other thing about scope is if I actually output, see I'm calling tick here, tick is going to be called, and this value of tick, which I don't actually reference in here, I don't reference this in here, is actually the global object. So that's how easy it is to reference the global object when you don't want to reference the global object. And tick is, it's like a callback, but it's being called back by the timing mechanisms in I'm out of time. So this is your final thing. Any questions? If you have some questions, the best thing to do is probably to come and see me at the DevExpress booth. I shall be here. Yeah, question?
When you are inheriting objects from other objects using prototypal model, that time we are getting all the properties that base object has, and we can redefine our own properties.
Yes.
Is it possible to splice some properties, like not to have some properties that was using in the base class?
The way the whole thing works is when you're reading a property, you go down the prototype chain. When you're writing a property, it goes on the object itself. So that's the way of doing overriding a method, for example, or overriding a property value. You just set the property on the outer object, the top object, and then when it comes time to read it, you don't go down the prototype chain because it exists on the top object. If you want then to have a look at the previous value, just delete it. Delete that property off the top object, and we go down.
That kind of syntax is available for deletion of some properties.
Mm-hmm.
Sir, another question is there. Sir, in C#, we faced both pass by reference and pass reference value by value.
Pass by reference and pass by what? Sorry.
Pass by reference is one,
yes,
and pass reference by value.
Oh,
in general cases, in C#, we are considering only pass reference by value, and pass by reference we are using rep. So in JavaScript, you mentioned that objects are passed by reference. So I want to clarify that the way I am thinking, that is correct or not. Means I am thinking that pass by reference or pass reference by value, and that.
Okay. So in C# you have 3 methods of passing an object. You have just the ordinary, which is passing by reference. If you alter the object, you're altering wherever it came from.
Yes.
You have the ref version,
yes,
where you're, and then you have the out version, where you're essentially saying, this is going to appear from this, you don't have to pass anything in.
Yes.
And JavaScript is just the first type. You're just passing objects by reference. That's it.
Okay.
Yeah.
Thank you, sir.
Okay. Time out. I'm being told.